In this video, we're going to talk about FullChip's Pattern Matcher. Of the applications and features, we're going to be focusing on these. We're going to talk about the Pattern Matcher and how we can use Pattern Matcher for rules-based SRAF placement, multi-patterning decomposition, and retargeting. So the Pattern Matcher allows the user to specify a target pattern to look for. Not only can you specify the pattern, but you can also specify whether to look for it rotated or flipped, and you can put constraints on the sizes of these cells in the matrix. This has several important applications. We'll talk about 3 of them and how we've used them in our examples. So when you do multiple patterning decomposition, it may be necessary to break a polygon into multiple layers, to split it amongst multiple layers. In order to do that, we need to identify possible breakpoints to be tried or tested. And the way we can do that is with Pattern Matcher. In this case, we're looking for basically a line, a space, a line, a space, and a line. And then here we find it. Now there are other pattern matches you could do. You could find this spot here by just going a space, a line, a space. Then you can put constraints. In this case, we put the constraint that the line, the space has to be 24, the line has to be 24, the space has to be 24, and there's a certain width that we have to have. Once we find that, we can put down a marker, these yellow things. We can put that down programmatically. We have the coordinates of all of these elements in the matrix, and then we can put down the marker programmatically there. So then the pattern decomposition algorithm can use this technique to figure out where possible places to break polygons might be. Another use for Pattern Matcher is in retargeting. In this case, just as an example, we want to do a bias of all edges, except we don't want to bias edges that are line ends of a 24 nanometer wide line. This is an arbitrary choice. It's just being used as an example to show how we can do retargeting, how we can use Pattern Matcher to do something in retargeting. So if I were to just apply a bias to all features, then all edges would move by whatever, 5 nanometers or 8 nanometers or whatever we're asking for. But in this case, what we're going to do is we're going to contract the line ends before we apply the bias. And we're going to contract them by using the Pattern Matcher to find them, laying down a marker, and then subtracting that marker. So in this case, we're looking for the pattern for a line end. So here's the line end, the 1 here, and we've got these zeros. Then we're going to look for this in all orientations. A north going line, a south going line end, an east, and a west. And when it finds them, we're going to place a marker that's 5 nanometers wide at the line end. Once we find them, we're going to subtract them away. And so we have a new layer. We do the Boolean operation here to subtract the red layer from the blue layer. And now we put the result on this cyan layer. And now we've basically shortened the 24 nanometer lines by 5 nanometers. See, we've shortened this one, but not this one. Now we can go and apply a bias, that's step 3, to everything. And the end result is that when we compare it to the target or the original we've moved all edges except these line ends here. Finally, I'm going to talk about SRAF placement, rules-based SRAF placement using Pattern Matcher. So in this example, we need to put SRAFs down, and we're going to do it in a rules-based approach. It's going to look like this when we're done, but let's see how we use the Pattern Matcher to do that. It's going to be 5 steps. First, we're going to place vertical SRAFs. Then we're going to bias the original mask features to create a buffer zone around the original mask features. And we're going to bias the vertical SRAFs to create a buffer zone around them. Then in the space left over, we'll add horizontal SRAFs, and then we'll merge everything together. Merge the vertical and horizontal SRAFs into one layer. So we use the pattern matcher to, again, look for, it's not really a line end. I mean, it looks the same pattern as a line end, but with the different constraints, we're looking for a real fat line. And then once we find it, we're going to put down markers. Now, I'm not showing you the details of how that's done, but you can imagine that once you find this pattern, you have access to the coordinates, and then you can put a marker formulaically and programmatically using those coordinates. And so in this case, we actually put 2 SRAFs down. Then what we do in steps 2 and 3 was to bias. So we take the original features that are the mask features, and we apply a bias to them, and then we take the SRAFs and we add a bias to them. This kind of creates a buffer zone around them. And now we have the free space in here where we are going to put our horizontal SRAFs. So in this case, we search for the pattern 101, and then we can put constraints on this saying we want it, we want a certain size 0 here, a certain height of this cell, the 0 cell, a certain height of this cell, a certain height of this cell. And then once we find them, we put down the horizontal scatter bars, again, as markers based off the coordinates of the pattern match. So then we merge together the horizontal and vertical, which are on different layers. That's on a pink layer and that's on a gray layer. And then we merge them together to create their SRAF layer. Now, you can also do other operations. You can say, okay, looks like I should put SRAF here. So then you can pretty easily devise a rule using the pattern matcher to look for a space like this and put down 1 SRAF. And then you could find more and more special cases and keep placing SRAFs.